Welcome to our lesson on factoring using the distributive property. So our last lesson looked at factoring with special products, and before that we looked at different ways to factor some trinomials. Now we'll be adding a couple additional pieces based around the distributive property. So the distributive property, reminder again, ends up with you factoring something outside of parentheses. So for example, if I was to use the distributive property on a problem that was like 2 times x minus 4. So the distributive property is what tells us to take the 2 times the x and the 2 times the 4. So your final answer here would be 2x minus 8. So just a refresher on the distributive property quickly. So then, looking at today's pieces, we're also looking at the idea of a greatest common factor. Now, greatest common factors can be number, variable, or a product of number and variables that goes into every term of the polynomial. So we'll explore that in our first few examples here to make sense of this idea of the greatest common factor now being more than just a number in some cases, also being a variable or a mix of a number and multiple variables. So if we look at A, negative 5x plus 20, what we're looking at are two different terms of negative 5x and a positive 20. So we want to think what is a factor of each of those, or what can be divided out of each. So both of these terms can be divided by a negative 5, because we have a negative 5x, positive 20, both are divisible by negative 5. So I'm going to factor out the negative 5, which would come outside the parentheses. And in parentheses, I'm left with a positive x, because negative 5x divided by 5 gives me x. And the positive 20 divided by the negative 5 gives me a negative 4. Now looking at B, we have three different terms. 3x squared minus 12x plus 9. So the greatest common factor has to be something all three of these can be divided by. So since the final number doesn't have a variable, I know I won't be factoring out a variable. Now what can 3, 12, and 9 all be divided by? Would be a positive 3. So I'm going to factor out the 3, and then on the inside, I would be left with, if I divide each of these by 3, x squared minus 4x plus 3. So for this lesson, we're just going to stop there. There is a way where if we wanted to factor it a step further, which we'll look at in later examples, we could go a step further with this to get what you see below. Now in C, we have 5x to the third plus 2x squared minus 4x. So in this case, we could divide each piece not by a number, because 5, 2, and 4 don't have any common divisors other than 1, but we could factor out the x. So if we factor out the x, we would have on the inside 5x to the second power plus 2x minus 4. In D, 14x to the third minus 77x squared minus 42x. So each of these terms shares at least one x, So I know I can divide out an x. Also, I can divide out 7 because the numbers out in front are all divisible by 7. So this time around, we're going to factor out the 7x as our greatest common factor. So then left on the inside, divide everything by 7x. So 14x third becomes 2x squared. Negative 77x squared minus 11x minus 42x becomes minus 6. In E, we have 4x to the fourth minus 12x squared. So now each of these has at least an x squared in it. So I'm dividing out the x squared along with the 4. So my greatest common factor is 4x squared. So if I divide each piece by 4x squared on the inside of the parentheses, I'm left with x squared minus 3. And then in F, we have our three terms, negative 2x to the third plus 10x squared minus 2x. So our greatest common factor, everything can be divided by a negative 2x. So left on the inside of the parentheses then would be an x squared minus 5x and a plus 1. So again, for greatest common factor, you're looking for a number, a variable, or a mix of number and variables that can be divided out of every term, and then we factor that by undoing the distributive property or dividing each part by what we're factoring out. Now we get into the idea of grouping. Grouping is a form of using factoring in the distributive property, and the key here is when we're dealing with 4 terms. So no longer trinomials. Now we have 4 terms. So the idea is to group the terms together, factor out the greatest common factor of each group, and then rewrite as a product of 2 binomials, meaning multiplication. So the first thing we do, step 1, is group the terms. So the first 2 terms get grouped in parentheses, and the second 2 terms get grouped in parentheses. Now in the first grouping, we're looking to factor out the greatest common factor. So 6x squared plus 8x, we can factor out 2x. That leaves us on the inside with 3x plus 4. Now we have to do the same with the second binomial of 15x plus 20. In this case, our greatest common factor, both terms, 15x and 20, can be divided by 5. So then on the inside, we're left with 3x plus 4 again. So the final step is to rewrite as a product of 2 binomials. So in this case, using the grouping method, we group together what's on the outside. So the 2x plus 5 becomes our first binomial, being multiplied by 3x plus 4. Now, if we would FOIL this, you would see it turns into the same piece as here. So the grouping method works when it's written as 4 terms. In B, we have 5x to the third plus 5x plus 2x squared plus 2. So we have 4 different terms. So we group together the first 2 and the second term in parentheses. Then, looking at our first grouping, 5x to the third plus 5x. Factor out the greatest common factor, 5x. That leaves us with x squared plus 1 on the inside. Then our second binomial, 2x squared plus 2. Factor out the greatest common factor, 2, and we're left with x squared plus 1 on the inside. Then we group together the two parts on the outside. So 5x and the positive 2 is 5x plus 2 being multiplied by what's left in the parentheses, same on both, x squared plus 1. So you'll notice, looking at A and B, when we factor out the greatest common factor from each group, what should be left in your parentheses is the same value of both. Same thing here, x squared plus 1, x squared plus 1. If you're not seeing the same thing on the inside, you're probably missing something with your greatest common factor. Now if we look at C, we have x to the third plus 7x squared minus 3x minus 21. So we group our two different binomials. Then we look at the first one, x to the third plus 7x squared. We can factor out x to the second. So left on the inside would be x plus 7. Now it's subtraction in between these. So I'm going to keep my negative here. And then the 3x minus 21 piece, if I'm factoring out the negative 3. On the inside, my minus 3x becomes a positive x, and my minus 21 becomes a plus 7, because both of these, negative and negative, divided by that negative 3 on the outside, gives us the x plus 7. So then when we rewrite this, what got blocked by the hole punch should be an x here. So we'd have x squared minus 3, take what's outside, the x squared minus 3, times, same thing on both insides, x plus 7. And then when we look at D, again, 4 terms, so we group the first 2 and the second 2. So in this case, 3x to the fourth plus 6x squared. So we can factor out a 3x squared as our greatest common factor on both, and that leaves us with x squared plus 2. Now the second one, we have a negative, because of the subtraction, negative 5x squared minus 10. So if I pull out that negative 5 as our greatest common factor, we're left with x squared plus 2. So then our answer, x squared, or 3x squared minus 5 times x squared plus 2. And again, if we would multiply this out and FOIL it, you can check, and it would give you the same piece here. So you can always FOIL these final answers to double check to make sure they come out to be this. So then we move into this final idea of factoring completely. So now that we've studied different ways to factor trinomials, binomials, 4 different terms, different special products, we can do this idea of factoring completely, which means factor as far as possible or break things down as far as we can go based on what we know. So, couple of shortcut bullet points there. If we only have 2 terms to factor, that tells us most likely we're going to be dealing with the difference of 2 squares. If we have 3 terms to factor a trinomial, it's possible it might be a perfect square trinomial, but otherwise we're left with just the idea of foiling backward or our standard factoring approach. And if we have 4 terms, you should use the grouping approach that we just went over. So looking at A, the first thing is I know it's a trinomial, so I'm going to look, though, to factor out a GCF if possible. So if I have a 2x squared plus 18x plus 36, all 3 terms can be divided by 2. So first thing I do is factor out the 2. Then what's left on the inside, divide each part by 2, and we'd have x squared plus 9x plus 18. So the 2 on the outside just comes down with our answer, and I'm left with this trinomial on the inside. So I'm going to undo the foiling or factor that. So factoring x squared plus 9x plus 18, I need something that adds to 9x and multiplies to 18. So that'd be 6 and 3. So it would be 2 on the outside still. And then when we factor the trinomial, x plus 3 times the quantity of x plus 6. So in B, again, we're looking to factor out a GCF if possible. Each part here, negative 12x squared minus 40x minus 28, can all be divided by a negative 4. So when we do that, on the inside, that leaves us with 3x squared plus 10x plus 7. Then to factor the inside, we need to look at undoing the FOIL approach, and 3x and x are my first terms. It's addition on both, so I know it's a plus plus. And then factors of 7 are 7 and 1. So 3x plus 7 times 3x minus 1. And again, if we'd multiply this all out, you can double check your answer. So C and D, same idea here. First step, factor out greatest common factors. So in C, I'm pulling out a 7x. Leaves me with 2x squared minus 11x minus 6 on the inside. Factor the 2x squared minus 11x minus 6, and that breaks down to 2x plus 1 times x minus 6. So when we factor completely, we have 7x times 2x plus 1 times x minus 6. D, 3 terms again, factor out the GCF. So all those terms can be divided by 10x to the third. Leaves us on the inside with 25x squared minus 80x plus 64. In that case, 25x squared and 64 both are perfect squares, so I have a perfect square trinomial. So I can just factor that down to a squared, or a minus b, from the a squared minus 2ab plus b squared. So I have my 10x to the third, and then when I factor the inside, it's 5x minus 8 times 5x minus 8. So I can write that as 10x to the third multiplied by 5x minus 8 in parentheses to the second power. In E, I only have 2 terms, so I'm looking at the difference of 2 squares. So square root the first and the second. Square root of x to the fourth is x squared. Square root of 16 is 4. So I have x plus 4, or x squared plus 4, times x squared minus 4. Now, x squared plus 4 can't be factored any further. X squared minus 4 is still the difference of 2 squares. So if I square root both of those, I get x minus 2 times x plus 2. So in this case, it went difference of 2 squares and then difference of 2 squares again. In F, we can first factor out the 5x, and we can make it a negative to make the inside first term into a positive. So I'm going to divide everything by this negative 5x. So that would leave me with negative 5x coming to the outside, 4x squared minus 9. Then negative 5x stays on the outside. I need to look at the 4x squared minus 9 and see if that can be factored down. 4x squared minus 9, both are perfect squares, so I know I have the difference of 2 squares. So in that case, that can be factored to 2x plus 3 times 2x minus 3. G and H, I'm going to just let you work through there. You can see the work and the process. In G, it's another grouping problem because it's 4 terms. Same with H. So you would use the same grouping approach that we used earlier. But then, when we get to the later steps, if you have 16x squared minus 49, because it's a difference of 2 squares, we can factor that one step further to 4x plus 7 times 4x minus 7. Same thing looking at H. After we factor it and group it, we want to check these last terms, 9x squared plus 1 and 5x plus 1, to see if they can be factored any further. In this case, they can't, so we're done. So the last thing we want to look at is how do we solve when they're 4 terms or bigger problems. So the approach is still the same. We want to write them in standard form equal to 0. So in A, we're already in standard form equal to 0. It's 4 terms, so I'm going to use the grouping method, and I end up with x squared minus 1 on the outside. On the inside, I have 3x plus 2. So that becomes x squared minus 1 times 3x plus 2. Both are equal to 0. X squared minus 1 can be factored down, though, difference of 2 squares, to x plus 1, x minus 1. And then we have 3x plus 2. So each one of these gets set equal to 0 to give us our answer. So x plus 1 equals 0 gives us the answer of x equals negative 1. X minus 1 equals 0 becomes x equals 1. And 3x plus 2 equals 0. Subtract the 2 and divide by 3 gives us x equals negative 2/3. Then in B, we have to rewrite it in standard form. So 21x to the third minus 35x squared minus 14x equals 0. Factor out the greatest common factor is 7x. We're left with 3x squared minus 5x minus 2 in parentheses equals 0. Factor the trinomial on the inside. So on the outside, we have 7x. Then on first binomial, 3x plus 1, second, x minus 2. So set each of those equal to 0. 7x equals 0 means x equals 0. 3x plus 1 equals 0. X is a negative 1/3. And x minus 2 equals 0. X equals 2.